Hey everyone, today we're going to talk about Rose curves. Okay, so different types of polar equations. So make sure you have the note sheet printed off and also make sure you have your calculator because I'm going to show you how to do some stuff in your calculator that's going to make your life a lot easier. You'll see here that the format of the equation when you have a Rose curve is right here. A sine of n theta or a cosine of n theta, where a is not equal to 0. Okay, these are called Rose curves. There's two really important things. If n is even, that means the rose has 2n petals. So double that n value and that'll tell you how many petals you have. If n is odd, then it just is whatever that number is. That's the number of rose petals that you have. Okay, so you'll see here a few examples. The first one, r equals a sine 2 theta. Because 2 is even, you double it, and that tells you how many petals you have. There's 4 petals. 3 theta, a cosine 3 theta. Since 3 is odd, there's only 3 petals. You'll see that there. 4 theta means there's going to be 8 petals. 5 theta means there'll be 5 petals. Okay, so that's really important. The next important piece of information is which trig function you're using. So I want you to notice something, and this will kind of help you as you're graphing it. When you have sine, okay, and you can go through and do this on each example, but you don't need to. If you go through and do your tests for symmetry, for sine, you are always going to have symmetry about the line theta equals pi over 2. So if you think about it of that vertical line, you're always going to be symmetrical about that vertical line. Now you may or may not be symmetrical about the polar axis, but you will always be symmetrical about the line theta equals pi over 2. If you go down here to the last one, sine of 5 theta, that's also symmetrical about that line theta equals pi over 2. If you look at these two that have cosine in them, they are always going to be symmetrical about the polar axis. Okay, so both of these are symmetrical about the polar axis. It may or may not be symmetrical about the line theta equals pi over 2. And it may or may not be symmetrical about the pole. But you will always have polar axis symmetry for cosine, and you will always have theta equals pi over 2 symmetry for sine. The other thing to note is that the size of those petals is dependent on what that a value is. Okay, so we're going to go through a couple different examples. If you look at the first example on your paper, we've got r equals 6 sine of 2 theta. So let me show you how to get the information out of your calculator, because this is going to make your life really easy. Okay? And actually what I'm going to do is I'm just going to move this screen in a tiny bit so that I don't have to flip back and forth too much. Okay. So in my calculator, what I'm going to do, let me get out of that. The first thing I want to do is put my calculator into the proper mode. We've always done function mode. You've always done function mode. If you scroll down to the fourth option, you'll see FUNC for function, then PAR is for parametric, and then POL is for polar equations. You've always had it in function command, but you want you to switch it over to polar. So that's the first thing. Okay, you can hit second and then the mode key to get out of that. And then if you hit the Y equals button, you'll see here that now your equations are in terms of R equals. Okay, so your calculator is prepared to graph in polar form. Now, before we do that, let's just clear up a couple of things. And you'll see that I was doing this before on my calculator. Let me clear out of here. Oops. Okay. You'll see here that I was just doing some calculations to look at the decimal values for my radian measure. And I just wanted to do that just to be sure of what I have, right? Pi is 3.14, so pi over 2 is going to be half of that, right? 1.57. Pi over 6 is going to be about 0.5235. And I was just doing a couple of them. But what I want you to do is this. If you notice, our graph goes in increments of pi over 12, right? It's pi over 12, 2 pi over 12, which reduces to pi over 6, 3 pi over 12, which reduces to pi over 4, 4 pi over 12, which reduces to pi over 3, then 5 pi over 12, then 6 pi over 12, which reduces to pi over 2, and so on and so forth. We can actually have our calculator do that as well. If you go to second window, that'll be your table set. And we can start our table at 0. And then for the change in our table, we can put in pi over 12. And that will take that, each part of our table will just go up by pi over 12. So if you go ahead and put in pi divided by 12, okay, then your table is going to go up by that much. So let's go ahead and put this equation in. I've got 6 sine of 2 theta. The theta button is the same place as the x. When you hit it, it'll come up with a theta because we're in polar mode. And now if you hit graph, you'll see what the graph looks like. Okay, so it's going to be 4 petals, which makes sense because it's 2 theta, and because 2 is even, we double it and we get 4. So that's what our graph is going to look like. If you hit second graph, it will give you your table, and it will give you all the values going up by pi over 12. Okay, so the first one is 0, 0. And then we have at pi over 12, we're here at 3, so 1, 2, 3. At pi over 6, we're at 5.2, so that's right about there. At pi over 4, we're up here at 6. And then we go back down and 0.5 over 2, or 5.2, excuse me. And then we're down at 3 for the next one, and then we're at 0. Okay, so that takes care of that first part. If you then scroll down in your table, we can go ahead and get the next set of values. So at 7 pi over 12, because we're just going up by pi over 12 each time, so it's 7 pi over 12. Now if you look at all of these values, they're all negative, so it's actually flipping them over the pole. So we're actually going to be filling in these values down here next. Okay, so 7 pi over 12, I'd be at -3. So I'm at 1, 2, I'm down here at -3. And then the next one, I'm here at -5.2, and then -6. And you can kind of get an idea of where this is going, right? That takes care. And then at pi, we are back at 0. You see 3.14, we're back at 0. Okay? And we can go ahead and look at the next set of values. Now we're down here at 13 pi over 12, so we're at 3, and then we're at 5.2, and then we're at 6, and then we're at 5.2, and then we're back at 3, and then we're at 0. And you can kind of get an idea because we already saw what the graph looks like. We still have to fill in this section here. And it's pretty intuitive at this point. We're just going to follow that same pattern, right? And you can get it off of the table as well if you're not totally sure. Right? We're down here in this fourth quadrant, but all of our values are negative, so that's reflecting us over the pole, or flipping us over the pole. Now we're up here. So I'm at 3, 5.2, 6, 5.2, and then I'm back at 0. So when you graph it, this is what happens. You graphing, because you should be able to graph it in one continuous motion. And so notice which way I'm going. I'm coming around this way now. Those were the next points that I plotted. And then I'm coming around here like this. And then I'm coming around here like that. And that's what your graph looks like, which is what it basically looked like when we graphed it there. Okay, so that's the idea behind graphing one of them. Let's go ahead and do another one. This time we're going to do cosine. So if I go back to y equals, all I have to do is change that to cosine. I kept the other numbers the same just so you can see the difference between the sine and the cosine curve. Okay, if you hit graph, you'll see what it looks like. Still 4 petals. Remember we said cosine was symmetrical about the polar axis, and it may or may not be symmetrical about the line theta equals pi over 2, which in this case it is. But if I go back to the table, so if I hit second graph, that'll take me back to the table. Again, I already have it set up to go in increments of pi over 12. So if I just go back to 0 here, so at 0 I'm at 6. At pi over 12 I'm at 5.2. And then I'm at 3. And then you'll see this weird value, negative 6e to the negative 13. Right? If you think about that, that's like 0.000000, right, until you have 13 decimal places and then you have the 6. It's basically equal to 0. I'm not sure why the calculator doesn't just put 0 here where it sometimes puts it and it sometimes doesn't. It must just be with the calculation that it's doing. But when you see something like that, just recognize that that's really the same as 0. Okay, so I'm down here at 0 for pi over 4, and then at pi over 3, I'm at negative 3. So that's putting me down here at negative 3. And then at 5 pi over 12, I'm down here at negative 5.2. And then I'm back here at negative 3. And then I'm back here at 0. Oh wait, 5. Oh, sorry, I missed my 6 there. Let me erase that one. It's supposed to be at, where was I? I missed one. Negative 3.2. Here we are. Negative 6 would be right there. That would be at pi over 2. Negative 6 flips it over. Okay, so then if I keep going and do my next ones, then I'm back here at negative 5.2, and then I'm at negative 3, and then if you see that again, I'm back at 0. And now for my next values, I am going to be at 3, 5.2, 6, 5.2, 3, and 0. And I think actually I plotted those points slightly off there. Let me go back and look at those again. Okay, so we did, let me go back. We did 1.57, that was negative 6, and then we did these values here. I did that negative 5.3, and I did negative 3 at 2 pi over 3 was negative 3, and then at 3 pi over 4 I was back at 0. Then at, here we go, 2.1, so I'm here, I'm at 3. I just had mine off a little bit. I was off by a tiny bit. 5.2, 6, 5.2, and 3. I was just off from my table slightly. And the reason that I knew that was because I knew I was supposed to have polar axis symmetry, and the way that I was doing it, it wasn't working out right. Okay? So again, if you graph this, you end up with one continuous line that you can graph. And of course, I kind of started in the wrong spot, but there's what your graph would look like. Okay, so that is r equals 6 cosine 2 theta. That's it for this video. I'll do the next 2 examples in another video, in the next video. Thanks, guys.